and turn around. All right, so we're not going to take half the class for you guys to fill out the evaluation forms, but please fill them out because I don't really want to get yelled at. But even if I do get yelled at, I'm just going to tell them, hey, the system is new, of course it's broken. And I'm not going to worry about it. I don't think they're going to fire me just for that. Okay. Before we get rolling into today's lecture, it is the last lecture of the term, the last scheduled lecture of the term. We won't have class tomorrow or Thursday. Which should give you time to work on your other class stuff, if you have other class stuff left to do. Looks like everybody got the group assignment 3 turned in. A few of you turned it in just after the clock ticked over. I fixed all of those already. Nobody turned in group assignment 3 late. So if it told you that you were late because it was like 12:02 and 57 seconds, we gave that to you. If I could make the assignment say due at midnight-ish, I would make the assignment say due at midnight-ish because nobody was going to start grading it at 12:05, right? We just have to pick a time. Okay, so group assignment 3, everybody's got that in. I looked at a couple of them just quickly. They look pretty good. So thank you guys for that. Now we know how to create a grading rubric so that it'll be easier for us to grade these next time. This time, what we're going to do is we're going to sort them. The best one goes at the top of the pile. The worst one goes at the bottom of the pile. Then we're going to compare the best and the worst and decide what the grade range is. The best will probably be at full score. The worst depends on how bad it is. If somebody didn't do nothing, then it could be nothing. But I'm guessing, based on the ones that I looked at, they all look pretty good. The worst one might be a low 90s, for all I know. So that stuff looks pretty good. The final exam, you guys, 1 attempt, right? It auto-grades that 1 attempt, but it's not quite done because there's an essay question, and the very first question is an essay question, which is worth 0 points towards the grade, if you didn't notice that. But you don't get a grade if you didn't answer the essay question. We know that some of the automatic grading, there are a couple mistakes in the automatic grading. So when it tells you your grade, especially if you opened the exam before we fixed those problems, when it tells you how many you got right and wrong, that might not be correct. If you believe something was marked wrong, but you should have been marked correct, so check your work before you complain. But if you believe it was scored incorrectly, go to the same form for late. So if you hand something in late and you want to get consideration for the late points on that, you can find that form in the syllabus under, okay, we're back. So if you think something got marked wrong and it shouldn't have been marked wrong, fill out the form so we make sure we capture that. If you email it, it might slip through. Of the ones that we know we missed, we've already regraded a bunch of those. So, all right, final exam. We know there's a couple mistakes on the auto grading. Won't affect everybody. Will more likely affect you if you opened the test on the first day and then didn't finish it yet, because it doesn't let us change your question once you've opened it. So even though all we're doing is making it easier for you to get the points for the question, we can't make that change online. The system doesn't let us. Okay. Today, in class, I took this class, the first lecture of the term was about safety. And that kind of makes sense for a lab class, right? Kind of makes sense to have the first lecture of the term be about safety. But for me, when I teach the class now, the last lecture of the term is about safety. Now, the last lecture of the term is about safety. Now, why is that? Save the best for last. Why would, first off, let's say, why would we do the first lecture about safety? Because you guys are about to go walk into the lab and we want you to be safe in the lab. How did we handle that in this class instead of having that be the first lecture? What's that? So we've got the TAs, the PLAs that are in the class, but it's beyond that, right? What did we do before you guys went into lab? We had you guys go through the process of becoming a user of the facility, the same process that anybody that was going to use the facility had to go through. So you had to go on your own, read what the safety policies are, and then take that little quiz that says that you did read those policies, right? So that's how we handle that part of it for this. Now, why do design of safety systems at the end of the term instead of the beginning of the term? Because it's not a random choice. It didn't just happen. Yeah.
At the end of the term, do we have maybe a little bit more of a clue of like what we'd be designing the systems for?
You guys have a clue. Anything else we might say besides clue? Yeah?
We're doing our lab practical.
You are doing your lab practical. What do you have to do to pass the lab practical? Somebody, what do you have to do to pass the lab practical? Yes?
Successfully engrave your part.
Successfully make the part. Happens to be you're doing an engraving on a piece of part that you already have. And what are the points scored on? I think I told the class how we developed the checklist, right? It's from the I broke this emails. When somebody sends an email to ibrokethis@wpi.edu and tells us what went wrong, we, especially if many come in that are similar, we reevaluate, should we change the policy in order to make that accident not happen again? And so we built that safety checklist. How many steps on the checklist? Somebody said it's 6, right? What's the aim of the checklist?
To avoid breaking things and students.
The primary goal of the checklist really is to not break machines. Right? If you look at the steps on the checklist, the primary goal of that checklist is to keep us from breaking the machines. Now, it has a side effect of keeping us as operators not broken also, because if the machine's not broken, it's not likely to break us in its breaking, right? I showed you a picture a while ago of the can opener on the back of the CNC lathe, right? Where the workpiece flew out of the chuck, bounced off the front door, and out through the sheet metal in the back of the lathe. I've seen, actually, if you look at Mini Mill 3, if you go back in the lab, if you're standing in front of Mini Mill 3 to operator's left, look at the sheet metal on the side there. It ain't flat. Now, what causes it to be not flat is the workpiece coming out of the fixture and hitting it with, what's the word? Kinetic energy. Right? The workpiece contains kinetic energy right up until it hits the side. Well, then it still does because it falls, right? But it's that energy. What does the energy do to the side of the machine tool? Work. The energy does work on the side of the machine tool, and it did plastically deform it in this case. So one of the reasons we do this safety lecture at the end of the term is we're talking about designing safety systems. Because when you guys get out in the field and are practicing engineers, no matter what you design, you're going to have to think about safety at some point. And you may have the job of designing a safety system for number one item on my job description here for my job at WPI is ensure the safe operations of the facilities. So how do I ensure the safe operation of the facilities? One, that damn word operation makes it harder to be safe, right? I could ensure safety by locking the doors, right? But since it says safe operations, I can't just lock the doors to make sure it's safe. So, all right, so that's why we do this lecture late. How do doctors kill people? Yeah.
Not being careful.
So doctors might kill people by not being careful. So, how do doctors kill people? Somebody else? So, mistake? Yeah.
Not following protocol.
So mistake, what is there a one word for not following protocols? Okay. You guys know idiot translates into not following protocols for the sake of this discussion. Anytime we say not following protocols, we'll just say idiot. You ever notice? Who drives? Who's driven a car? Who's ever been passed by somebody when you didn't think it was good for them to pass you? Who's ever really wanted to pass somebody because they were going too slow? All right, so you pretty much all experienced this, right? When you're driving a car, if somebody is going fast, I want to phrase it right. If somebody's going slower than you, they're an asshole because they're in your way, right? And if they're going faster than you, they're an effing idiot, right? Not following protocols. Okay, so mistakes. Not following protocols. How do doctors kill people? Let's get some more detail. How do doctors kill people? Because doctors kill people, right? One of the major causes of death in the United States is doctors. Look it up. It's true. How do doctors kill people? Yeah?
Thinking they know more than they do. So
So
being carelessness, but then
the other side of idiot, I guess, right? So there's like simple procedural mistakes. There's failure to follow procedures. There's informed misdiagnosis, right? So it's certainly not on purpose. They believe that they've made the correct diagnosis, right? So at what frequency do doctors kill people? These are the primary reasons, I think. At what frequency? Typically. I mean, it could happen, right? So a doctor could develop some biological agent and accidentally unleash it on the public. But that doesn't typically happen. In fact, we don't have any evidence that it's ever actually happened except in the movies, right? What frequency do doctors typically kill people? Yeah. A few thousand times a day, but it's really one at a time, right? How do engineers kill people? Engineers get to do it by the thousands, right? So there's some statistics that they'll say here at the beginning of this movie. Some volume. Can you guys hear? We won't watch the whole hour.
In 1968, at the height of the war in Vietnam, 14,000 Americans were killed and 46,000 were wounded. That same year, another 14,000 Americans were killed. But those lives were lost right here in the United States because those American men and women were killed at work, on the job. Another 2.5 million American workers suffered disabling injuries. That's 54 times the number of people we had wounded in Vietnam that year.
The subcommittee will be in order. This morning, we're continuing with our oversight hearings of the occupational safety and health.
In an effort to stem this tide of injury, disease, and death, Congress created the Occupational Safety and Health.
All right, so one way engineers could kill people.
In creating OSHA, Congress affirmed the right of every...
One way that engineers could kill people is by making bombs, right? Anybody know what the what's the word? The prime directive. It's not the prime directive. It's right on the thing as you walk down the stairs in Washburn. What's it called? Yeah. Hold paramount the safety of the public. And it says right underneath it what it is. It's the professional engineers creed standard of. We're gonna have to walk over there and look at it in a minute. But hold paramount the safety of the public. Which I think, if your job as an engineer is building bombs, means don't blow up the wrong people. But in general, so anybody seen the videos or pictures of the Tacoma Narrows Bridge? You guys know what the Tacoma? Do you know that was a WPI graduate that designed that bridge?
Oh no.
By the way, anybody that hasn't seen the Tacoma Narrows Bridge, you can look it up on Google. But they built this bridge across a narrows, so it's across the ocean basically, but a narrow point in the ocean. And they built this bridge, and the way the wind blew, and the spacing of the support structures would set up a harmonic, a resonance. And it actually made the bridge deck do this. Like it was literally moving up like 5-10 feet and back down. And over time, the bridge got weaker on with it. Yeah, my grandparents actually drove across the bridge. This was a thing that people would do on a date, is you'd go drive across the bridge and have your car do this as you're driving across the bridge. So when that bridge collapsed, nobody died. The designer almost died. He was on the bridge just before it collapsed, and because he was still trying to figure out what was wrong. And he ran off the bridge. I think there might be a video of him running off the bridge just before it collapsed. So now this had an obvious flaw. The bridge deck is doing this. You can kind of decide, let's close the road. But there's been bridges that have collapsed, right, with cars on them, just because they collapsed. Happened not too long ago. So there's been buildings that have collapsed in situations where they shouldn't have collapsed. If you build a building in an earthquake area where you're supposed to design it to standards so it won't fall down in the earthquake, and then the building falls down because the earthquake that was within those parameters happens, that's an engineering mistake, right? When the space shuttle blows up, that's an engineering mistake. So engineers get to kill people in volume, while doctors only get to do it one at a time. So this is one of the reasons that we talk about safety systems. So in the video, you might want to watch the whole thing sometime, but the video talks about why we founded OSHA. Does anybody know what OSHA is? Anybody in the back of the room that doesn't normally answer questions know what OSHA is? You sort of had your hand up over there. No? You just sort of get a new pose. Who else? Somebody here had a hand up. What's OSHA? Government. Organization. You guys got that 2.5 million people injured, workplace accidents, 1968, 14,000 killed in the United States. Government organization for workplace it's the Occupational Health and Safety Administration. It's one of those things where it's a detail, I look it up. What's this? Oh, look. This is Jiaolong's OSHA 10 card. It's the Occupational Safety and Health Administration. Yeah, we had it right. Who's the customer of OSHA? OSHA has a customer. Who's the customer?
Workers who get injured. Engineers to get certified.
Actually, OSHA licenses people to do the certification. I don't think they do the certification themselves.
Okay.
But The customer really is the worker. And OSHA exists so that the worker doesn't die. When you guys are working in the lab over here, are you covered by OSHA?
Yes.
Are we obligated to maintain OSHA safety standards when you guys are working in the lab?
Yeah.
Only if we're giving you a paycheck. Students don't count. I actually went to a meeting of university administrators and safety people for all of New England, and this question came up. So if OSHA requires that if you have an accident at your facility and 5 people go to the hospital, or 1 person dies, at least 1, it could be 5. If somebody dies or 5 people go to the hospital, you are legally obligated to report it to OSHA within 24 hours. Failure to do so is a criminal offense, and you go to jail for not reporting it, regardless of who's to blame. And so this question came up, well, what if it was 3 students and 2 employees? And there was much debate, to my chagrin. Because I'm like, I said, what's the downside of reporting it if I didn't have to? Well, you bring OSHA's attention to you. But if I just sent 5 people to the hospital, I might need their help, right? So anybody worked at a company where OSHA inspection happened when you were there? Yeah. You got a story about it?
We got in trouble.
You guys got in trouble? Yeah, they always write fines, right, when they show up. Any details of what the problem was that you remember? What?
And there was too much chlorine in the same area as like other chemicals, it's got like,
So chemical storage was dangerous?
yeah.
Yeah. Anybody else got a story? Yeah.
I don't recall a lot of the fines, but I know that in the machine shop that I worked in, you're not allowed to open the doors, so we unhinged all of that so that way the sensor's not there. So if OSHA were to come in, because we have a lot of the other facilities coming in and checking, but if they would come in and see that, we'd be like super in depth because like all of our machines are able to open the door.
Yeah. So what they did is they overrode the safety interlocks that makes it so the door doesn't open, so that you can interact inside the machine while it's cutting. And it's not necessarily an OSHA violation to have a machine that doesn't have the safety interlock. It is an OSHA violation to disable the safety interlock. Interesting side point there. So somebody else had their hand up? Yeah.
So my company, I wasn't there, but we had to, they told them basically they had to wear gloves while soldering because the lead.
Okay.
Yeah.
So WPI had one a couple years ago for, it snows here in the winter. Anybody been here through winter? Yeah, it snows here. Sometimes they have to shovel the snow off the roof. So there was people up on the roof shoveling snow off, no safety harness, no handrail on the edge of the roof. So WPI got in trouble for that a few years ago as a contractor, but still we got in trouble for it. There was a machine shop at WPI that, and so why does OSHA come do your inspections?
To make sure that you are.
But what instigates them to come? They come to make sure that you're in compliance. But usually what instigates them to come is some complaint. So it's not always a complaint. In especially construction sites, they just go around and they check them randomly. But usually it's a complaint. So somebody had complained to OSHA about a particular machine shop at a different department. And the OSHA guys came in. And it turns out that everything that the person had complained about was no problem. But since they're here, they get to look at everything, right? They don't just look at the stuff you complained about. So it turns out there was no violations attached to the complaint. They did, however, issue $17,000 worth of fines for other things that they noticed. So when I get the email, OSHA, machine shop, fine, meeting, these are the words that I saw, right? And I'm like, shit. And then I read the email, it's like, and we want everybody to come look at your lab because your lab sets the good standard for the whole. Oh, good. It wasn't my lab. All right, so, but OSHA's there to protect. I got one more OSHA story. Company that I worked for in the summer when I was going to WPI. This summer, I had a summer job working for a construction company building a bridge across a river. The day I got there was the day the last piece of steel got set across the river. And so what we did is we set all the concrete forms and poured all the concrete and stuff like that and made the bridge deck across. And so the day I started work, OSHA showed up for an inspection. The guy wrote a $10,000 fine before he got out of his car. Because when he pulled in the parking lot, somebody else was riding up in the bucket of a backhoe out of a hole. You don't ride in the backhoe bucket. And the hole was too narrow. The guy never should have been in the hole to start with. Right? So later that summer, a different bridge job, you use a lot of cranes and stuff when you build bridges. Cranes are cool because they can lift boxes of stuff closer to where you're working. You don't have to carry all that stuff. That's nice. You like the cranes. So we had a box that you could get lifted up, and you could stand in the box, and you could work on the side of the bridge. Except we weren't supposed to have one of those. So a call comes on the radio. The OSHA guys on site knock all the handrails off the man box. And of course, as dutiful employees, we did. We went and got our hammers out and we cleaned everything up so that it looked like it was just for moving equipment. Who's OSHA's customer? The worker. Now, our man box was probably safe, but there's rules for those boxes. They have to be inspected by a professional engineer every 6 months, and they put their stamp on it that says it's okay. Ours had never been inspected. Right? It was probably okay. I mean, we used it for years. Nobody ever got hurt. But OSHA's there to protect us. So as employees, don't do shit to subvert OSHA. Follow the rules. You can actually ask them to come and give you a courtesy inspection. Say, hey, we're wondering, is this workplace okay? Can you guys come look at it? And give us feedback about what we need to do to improve the workplace. Typically, if you ask them to come as the employer, they'll look at it and they'll give you the feedback. And typically, they won't write a fine as long as you fix it within a certain amount of time. So they're there to help us, not to fight us. But all right, so that's enough about OSHA. What's a safety system? Because this lecture is supposed to be about designing them. What's the objective of a safety system? Somebody shout it out.
Preserve personnel and equipment.
So say again.
Preserve personnel and equipment.
Preserve. I can't spell preserve, but I can spell protect. Right. Anybody live in a place that has fire sprinklers? An apartment or live on campus, I'm sure you have fire sprinklers, right? Maybe you live in a place that does not have fire sprinklers. If you live in a 3-decker in Worcester, you don't have any fire sprinklers. What are the sprinklers there to protect? The building. The smoke alarms are there to protect you. When the building catches on fire, get the hell out. Right? Smoke alarm is supposed to get you out. That's why the 3-deckers don't need to have sprinklers. In fact, I used to own a bunch of 3-deckers. Wanted to put sprinklers in them. I called the insurance company to find out how much my fire insurance policy would be reduced if I put sprinklers in. They said the rate would go up. They were more worried about water damage than they were about fire damage. Protect people and stuff. So, protect it from what? I like that. Objective. Protect it from damage. We don't want to get damaged, but what would damage it that we're protecting it from? Yeah.
Human error.
Human error could instigate the thing that caused the damage. What's the thing that causes the damage, typically to people and things? Something uncontrolled.
Stuff flying around.
Stuff flying around. Well, the flying doesn't hurt anything. Right? Jump off the building. It's not the jump that kills you. It's the sudden stop at the bottom, right? So it's when we transmit too much energy into it, when we do too much work on the thing, right? So from work. And not like send them to the break room so they don't have to work so hard. This is to keep us from doing physical work on the people or stuff, is a lot of what a safety system does, right? So how do we keep from doing physical work on stuff? Now there's other, wait, right, so protect people and stuff from hazard. There's other kinds of hazards besides physical work, right? Chemical hazards, right? You had a chemical storage problem, right? So we could get hazarded by breathing bad fumes too as people, right? Our stuff could get corroded by being exposed to the wrong mixture of water and coolant. So you know the coolant that we use in the machine tools is a water oil emulsion. If the water concentration is too high, the machine tools will rust. Rust is bad, right? So one part of our safety system is to periodically check the concentration of water to coolant, water to oil, to make sure that we're not in that range. So there's other hazards. What other kind of hazards could we have? Let's think about a machine shop. So there's the hazard of physical work. The workpiece comes out of the fixture and dents the sheet metal side of the machine. If you'd been standing there instead of the sheet metal, that would have hurt, right? We've in ME 1800 have pieces come out of the fixture and break the glass. Talked about that on the first week, I think. That was because the instructions didn't say to tighten the vise. That was the excuse. Fire. So hazards: fire, work. What else? Chemical. So fire's got two hazards really, right? Heat and smoke. I always tell the students when I leave to go to lunch, I say, I'm going to lunch, call me if anything catches on fire. That sounds fair, right? Like if it's short of a fire, I don't really want to know about it until I get back from lunch. But if it's a fire or something excessive, I want to know about it right away. One day I'm walking back from lunch, I'm coming around, walking up the hill, and there's like 2 fire trucks in front of Washburn. I was like, oh, somebody must have pulled the fire alarm. Nope, the ladder is extended. Nope, they're spraying water on the building.
I remember this.
But nobody called me to tell me that the building was on fire. That was the day that I learned. So this was before we had Canvas. This was when we used MyWPI, so Blackboard system. This was the day that I learned that I could use my cell phone to log into the Blackboard system to send an email to the entire class. The email said, due to the fire, labs this afternoon are canceled. They were working on the roof. Someone dropped a piece of hot something in between 2 walls. It actually smoldered inside the wall all day long before anybody noticed. I smelled the smoke. I thought somebody was cutting something on the laser cutter. So it was smoldering all day long. It was directly above that laser cutter, which caught all the water that they sprayed on the building. I actually got to go in during the fire. The fireman took me inside, so I got to unplug the machine and move it out of the way. But it had already been catching all the water for a long time. It was amazing. The cabinet was closed when it got wet. We waited 2 days, we plugged it in, turned it on, it worked fine. Didn't even lose the computer monitor. But yeah, fire. So how do we protect? So if we want to protect people from this, what could we do to protect? Yeah, so we could have rules. And those rules should be targeted at keeping people from doing stupid stuff. Does that make sense? So rules should be targeted at making sure that we don't allow hazards like this, or, yeah, we got work in here, to propagate to the people or the machine. So we could have policies. What else makes up a safety system? What are the components of a safety system? I'd agree. The first thing is policies. We've talked about some of the other things already today. Guards. So how do people get hurt by a machine tool? Let's just look specifically at a machine tool. How are you going to get hurt? So the picture here is part of the policy, right? The picture is a warning to operators. Let me go back just a hair. Well, that wasn't back, was it? There. The picture is a warning to operators that this could happen. What's the picture showing us? Anybody got it? Because it's kind of out of context right here. Yeah.
The lathe, or the material on the lathe is sticking up the back.
Right. This is the back of a lathe. There's a bar of material that's sticking out the back of the bar of the lathe. You notice the material can be longer than the part you're cutting, right? Inside the spindle, on these lathes we use spindle liners so that the material doesn't have room to bounce up and down outside of where it's supported. We support it inside a spindle liner. If you stick it out the back of the lathe, now anybody notice next to lathe number 1, there's one of those posts that holds the building up, has a big gouge out of it. Anybody seen that? Next time you go in the lab, take a look. There's a post right next to lathe number 1. There's a giant gouge out of it. The gouge is from this. Now, there wasn't a person standing there. There was the building standing there. The student who was operating the lathe, when he emailed, "I broke this at WPI," did state that as soon as I realized what the wump wump noise was, I hit the e-stop. Since nobody was hurt, and we could use it as a learning experience, we printed him a t-shirt. He Who Breaks the Building is his new name. But so it was, he knew not to stick the material out of the lathe. He knew it. In fact, he did it was because, well, he didn't want to have to cut it in half on the bandsaw first, because he only needed a little bit, and he didn't think it was going to spin that fast. So he was conscious of the fact that he stuck the material out. Don't let the material hang out of the back of the lathe. Some more warning symbols. So this is telling us that there could be an electrical hazard, right? This is telling us don't use our loose clothing and lean into the machine. Wear our eye protection. There might be bad stuff in the air. This one says wear gloves when handling saw band. Yeah, okay. When you're actually loading a new blade into the bandsaw, this is a warning sticker on the side of the bandsaw. When you're loading a new saw blade into the bandsaw, you might want to wear gloves. When you're operating the bandsaw, absolutely no gloves near the bandsaw. Why is that? Because there's loose material on the edge of your glove. If it touches the blade of the bandsaw, it will pull your hand into the bandsaw. This one's not my story. Professor Sisson tells this story when he was at Virginia Tech. They came in one morning, the machinist came into the machine shop one morning, and well, as they were approaching the door to the machine shop, they were following a trail of blood back towards the machine shop. As they opened the door, there's blood on the handles. They followed the trail of blood to the bandsaw. It was a faculty member who needed to cut a piece of wire. Couldn't find the wire cutters, but he knew there was a bandsaw in the machine shop. Took the wire, wrapped it around both hands, turned on the bandsaw, and then pushed it through, thinking it would cut the wire. Of course, the first tooth on the bandsaw that caught the wire pulled the wire straight down, pulled it in, took both thumbs off. Now,
when I was lab safety, this guy.
so, yeah, there's some bandsaw blade like that, yeah. So this one happened at WPI. Let's see. Incident report. We'll be able to read most of the incident report here pretty soon. Approximately report facilities member cut hand stated she forgot to remove drill chuck key, webbing of thumb, 22 stitches right here using a drill press. Put the chuck key in to tighten the drill chuck on the drill. Remember we had that question on the exam, I think? How much energy in the chuck key? Put the chuck key in, press the start button, As her hand came down from pressing the start button, that's when the chuck key came out. Now, we're actually lucky it hit her in the hand. Could have hit her in the forehead, right? But it hit her in the hand. It was interesting waiting with her at the emergency room for her parents to arrive. They had to drive in from Albany. And she was a little bit nervous because she said, usually my father brings me to the emergency room. Then I just had to wonder, I mean, there's a usually with emergency rooms? So so they make drill chucks that don't require those keys. You'll notice that those are the ones that are typically installed in our drills. They also make drill chuck keys that can't stay in the drill chuck. They get little springs and they pop out. In fact, those are the ones that we're supposed to have. Somebody had found this old drill chuck key and brought it out. It wasn't supposed to be deployed. Shouldn't have ever been there. When she got back in the lab, we gathered up anything that remotely could have caused that accident. She welded it into a sculpture. So, yeah. So, lab safety. So how do you keep that accident from happening? That particular accident. I gave you a couple ways. So this was not an inexperienced user. One of the most experienced users in the facility. What caused the accident?
Inappropriate tooling.
Well, I mean, at the instant it happened, it was operator error that caused the accident, right? And most of these accidents like this are caused by operator error at the instant of it happening. So one of the things our safety system should do is make it really difficult for that kind of operator error to happen with the policies. So I don't know if you've heard, this was now several years ago, maybe even, I can see, I have the date right here. 2011, when was that? That's 7 years ago. So about 7 years ago, there was a student at Yale that got killed in a machine shop. She was working alone in a lab after hours. Her hair got caught in the lathe. It actually pulled her head down, wrapped her around the material that was in the lathe, and she choked to death. It was a older belt-driven lathe. It actually stalled the motor, or it stalled the spindle. So the spindle didn't keep spinning. It stopped, but she was caught in it. And so the combination of that happening, so when that happened, it was like 2 o'clock in the morning, 3 o'clock in the morning. So 8 o'clock in the morning when I'm driving to work, I had a phone call from the department head. Because in the administration of universities, this kind of information gets spread very quickly. So you need to check on your machine shops. You need to make sure that this isn't going to happen again. So he called me and told me about it while I was driving to work. And the first question he asks is, how do we know this can't happen at WPI? And the immediate response is, well, we have good policies. That's the first thing that comes to mind. But before I even said that out loud, I said, yeah, but they didn't have crappy policies at Yale. I'm sure Yale had good policies too. It's a matter of how do you know that people are following the policies? And so we actually, we studied this a lot. We made a couple changes to our policies based on that happening. And then actually, even more when this incident happened at WPI. One of the first things we did was we had it so that, oops. So we started locking out all, and so we called it unguarded at the time. We actually had to fix that term. It's really non-interlocked. Because all the machines have some sort of guarding, some sort of safety guarding that we have. So we don't really have any unguarded machinery. It's non-interlocked machinery. And so what we did was we made it so that you had to have a higher level of access in order to be able to turn the power back onto those non-interlocked machines after 5 p.m., after the staff left. Now, that wouldn't have helped the girl who cut her thumb because she would have had that access. She certainly was at the level where she would have had that access. The other thing that we did, and you've seen this probably, is we put these safety shears on all the machines. And before we picked the shears that we were going to use, we tested a lot of them. You twist up a T-shirt in the lathe and see what could you use to cut through it. And so it turns out these EMT safety shears were the best tool that we could come up with. And so we put them on all the machines. In fact, using it for something that's not an emergency is grounds for being banned from the facility. It's only for emergency use. We put it there, it does two roles, right? It adds to the signage. It reminds you, and it gives you a fighting chance if you do get tangled up in the equipment. So those are parts of our safety system, those policies. What besides policies do we want to have in our safety system? We got policies, we've got guards and interlocks. What else do we want to have? Yeah.
Maybe people to make sure people are following the policies?
So we need something that makes sure, and it's really an adaptation of the policy. So the other thing that we did, and this happened, so when the girl got her thumb cut in the drill press, she was alone in the lab. Just like the girl at Yale that got killed was alone in the lab. Now, she didn't know she was alone in the lab. She thought there was somebody else there with her. When she started using the drill press, there was somebody else there with her. That person left without telling her. So when she actually got hurt, she was the only one in the facility. And so luckily, she went outside. There was a custodian. They called an ambulance. They brought her to the hospital. They called me. I met him at the hospital. This was like at 9 o'clock at night, too. We changed the policy. So there has to be a second person, right? And that's the rules. It's in the policies, right? If you're using one of these non-interlocked machines, you have to have a conversation with that second person that says, hey, I'm going to go use the bandsaw. Will you be my second person? And the person has to agree to be the second person. And so that way, that gives that second person a chance to look at you and say, hey, wait a minute, you got the little dangly things here. That's going to be dangerous. It could get you sucked into the bandsaw. So take your hoodie off or whatever it is. And make sure that that person doesn't leave not knowing that they were your second person. The other person left not knowing that she was only using the drill press because he was there. Right? So we made those changes to our policies. So work, guards, and interlocks. What else can we do?
Like data safety sheets, so like an informative.
So like the MSDS goes along with these hazards, right? And we used to have to keep them on paper in the facility. Now online is good enough. They've changed the rules. Yeah, they've changed the rules that you can have them posted on your website, and that's good enough. Which I suppose. But yeah, so, and if you're ever asked to work with some chemical, I recommend read the MSDS for it, especially if it's at work. Things like acetone are bad for you. Guards, policies, interlocks. What else goes into our safety system? Personal protective equipment. So that's things like gloves, like safety glasses, like a leather apron that you might wear if you're welding. And there's appropriate times to wear different PPE. So it wouldn't be appropriate to wear gloves when you're operating the bandsaw. It's not really appropriate to wear gloves when you're operating a bench grinder. It's certainly not appropriate to do welding without wearing gloves. It's not appropriate to do welding in your cut-off jeans. But people do it all the time. Think about placement too when you're thinking about these safety systems. So you can design things so these guards, that's to keep me from sticking my fingers where they don't belong, right? That's what guards do. The interlocks is to keep me from sticking my fingers where they don't belong when things are operating, because sometimes you have to stick your fingers there, so you have a door that gives you access. You do an interlock, that's a switch that doesn't let it operate while your fingers are in there. You got your personal protective equipment, the shop layout. What about litter? Anybody ever used one of the paper towels in the shop? What, dry your hands off after you take your part out of the machine? Right? What if there's no trash can to put it in?
Then you find a trash can.
Yeah, or Yeah, just leave it on the table. Maybe I got to dry a bunch of stuff off. I'll pile them up on the table here. We had a fire in the MQP lab in Higgins a couple years ago when there was a crumpled up pile of papers on the table. I believe it was wiping the hands kind of papers, but I'm not really sure. There was somebody on the other side of the workbench, there's a wall between them, grinding something. And they were doing a grinding operation to get ready to weld something. Now, the sparks go someplace when you grind something. And actually, the sparks are the coolest part about grinding stuff, right? The rooster tail of sparks that comes off the grinding wheel. Well, right over the wall, lit the table on fire on the other side of the wall. Now, they noticed, and they got a fire extinguisher, and they put the fire out. But could have been worse. What else we got? Looks like everybody's anxious to go. It says it's 11:50 on the clock. I guess we can go. Hey, I had a lot of fun having you guys in class this year. I hope that some of you had fun and that all of you learned something this year. And there was something I said at the partway through the term. If you learn only one thing this year, it should be that thing. Anybody remember what it was? I totally remember saying it. No, it's not the engineering haiku. Engineering's math, just a bunch of word problems. Oh, maybe it is. Cancel the units. Yeah. Engineering's math, just a bunch of word problems. Cancel the units. And if the units cancel, you probably got the right answer. Again, if you think there's a mistake in the grading of your final, make sure you submit it on the form. Don't just email because the email might get missed. But if you put it on the form for late assignment consideration, we won't miss it. Thanks very much. See you guys. Let's see. Opportunities to see me in class again. I teach this class again in C term. So if you didn't do so well, don't worry, there's another chance. I also in C term am teaching ME 3820. So you can see me then.
I'm doing Professor.
Good.
So I'm doing an IQP on the state of